Russia's deadly secret just took flight. NATO was completely taken unaware, while Russian engineers quietly turned their Su-57 fighter into something far more dangerous, a machine packed with sixth-generation technology that could change war forever. Is this Russia's greatest military breakthrough in decades, or the most desperate lie ever told? Join us as we find out every secret about the Russian sixth-generation fighter jet. Inside Russian airspace, 8 Su-57 prototypes have been flying missions that NATO never saw coming. These weren't ordinary test flights. According to Vladimir Mikheyev, a top advisor at Rostec Corporation, Russia has been secretly installing sixth-generation fighter components onto its existing fifth-generation platform. The testing began quietly in 2023, with new flight and navigation systems appearing on the PAKFA prototypes. Russian engineers weren't just upgrading software, they were rebuilding the aircraft's electronic warfare capabilities from the ground up. The new radar system operates as both a detection device and a reconnaissance tool, while the electronic warfare suite can track and jam enemy signals simultaneously. Over 700 test flights have validated these modifications, according to Sukhoi officials. Each mission collected data on how tomorrow's fighter technology performs in today's aircraft. The results have sent shockwaves through Western intelligence agencies. NATO's concern stems from a simple fact. Russia appears to be leapfrogging traditional development timelines. While American and European programs like NGAD and FCES are still on the drawing boards, Russia claims to have working sixth-generation components flying right now. The implications are staggering. If Russia's claims prove accurate, they've achieved technological parity with the United States years ahead of schedule. The Unified Electronic Warfare System alone represents a major advancement in combat networking, the ability for aircraft to share information and coordinate attacks in real time. But the most troubling development involves the aircraft's dual-mode capability. Russian officials have confirmed the sixth-generation platform will operate both manned and unmanned. This means enemy forces could face swarms of autonomous fighters working alongside human pilots, creating tactical scenarios no current defense system was designed to handle. The testing has also revealed advances in engine technology that could reshape aerial warfare. The new power plant delivers significantly higher thrust while consuming less fuel, a combination that extends operational range and reduces logistical vulnerabilities. This efficiency breakthrough allows the aircraft to perform supersonic maneuvers at extended distances without frequent refueling. Western analysts remain skeptical about Russia's timeline claims. The head of Sukhoi's design bureau stated the first true sixth-generation aircraft could take flight in the second half of the 2020s, suggesting current tests are preliminary rather than operational. However, the Advanced Research Foundation in Moscow has been working on multiple sixth-generation projects since 2014, focusing specifically on materials and engine development in cooperation with the consulting firm Lyulka. This parallel development track suggests Russia's sixth-generation program runs deeper than public statements indicate. The secrecy surrounding these tests has intensified geopolitical tensions. China's BIDE program and America's NGAD initiative suddenly face a competitor that may have achieved critical breakthroughs first. The global balance of air power, unchanged since the introduction of stealth technology in the 1990s, could shift dramatically if Russia's claims prove legitimate. NATO intelligence agencies are scrambling to verify the extent of Russia's technological advancement. Satellite imagery and electronic intelligence gathering have intensified around Russian test facilities, but confirming the true capabilities of these modified Su-57s remains extremely difficult. The stakes couldn't be higher. Air superiority has determined the outcome of every major conflict since World War II. If Russia has genuinely integrated sixth-generation technology into operational aircraft, the military balance that has maintained global stability for decades may be crumbling. But these secret tests revealed something far more chilling than upgraded radars and better engines. What happens when artificial intelligence takes control of warfare? Russia is secretly testing new versions of its Su-57 fighter jets, and they're not just upgrading hardware, they're experimenting with systems that let the plane make decisions without a pilot. These jets are using artificial intelligence to spot, track, and even attack targets on their own. This changes everything. In normal air combat, pilots rely on training and quick reflexes. But now these new systems can process information way faster than any human, deciding the best way to attack or dodge in just milliseconds. Tests show the AI can handle multiple enemies at once and even work with other planes during a mission. Russia's bigger plan is to pair human pilots with autonomous drones. One fighter jet could control up to 4 unmanned wingmen, flying in attack formations designed to overwhelm any defense. They're also pushing for hypersonic speeds, faster than 5 times the speed of sound. If successful, these jets could hit targets anywhere on Earth in about 2 hours. At that speed, most current defense systems wouldn't even see the attack coming. Stealth technology is also advancing. These planes aren't just hard to spot on radar, they're designed to avoid being seen by heat sensors, visual detection, and even newer surveillance systems. Russian scientists are working on special materials that help the jet blend into its surroundings. One of the most controversial parts is that these new systems can choose and hit targets on their own, without a human making the final decision. That's raising big ethical concerns around the world. While the United States and its allies are focused on keeping pilots in control, Russia seems to be racing toward full autonomy. And they're moving fast. Instead of building new jets from scratch, Russia is testing new tech on old models, which is saving them time and speeding up development. Meanwhile, Western programs like Europe's FCAS or Japan and the UK's GCAP are moving more slowly due to international partnerships and government red tape. Russia's centralized control gives it an edge in decision-making and execution. China is also in the race, working on its 6th-generation jet with different priorities, creating a 3-way global competition in future air power. These new jets won't just fight other planes, they might be able to shut down satellites, block enemy communications, and carry out a cyber attack, all without firing a single missile. In effect, they're flying computers that can disrupt entire military networks. Russia's tests show these fighters might even act like command centers in the sky, managing operations and blocking enemy responses all at once. Put simply, the mix of AI, hypersonic speed, and autonomous weapons is changing air warfare forever. Old strategies may no longer work in a world where machines fight faster, smarter, and without warning. While Russia experiments with tomorrow's weapons today, the rest of the world races to catch up. Who will control the skies of 2030? Russia's accelerated 6th-generation testing has triggered the most intense aerospace competition since the Cold War. While Western programs remain years from first flight, Moscow aims to deploy operational 6th-generation capabilities by 2030, a timeline that has defense planners from Washington to Tokyo scrambling to respond. The Russian strategy differs fundamentally from Western approaches. Instead of developing entirely new aircraft from scratch, Russia integrates advanced systems into existing platforms, validating technologies through real flight testing rather than computer simulations. This pragmatic method has compressed traditional development cycles from decades to years. America's next-generation air dominance program, by contrast, remains locked in conceptual phases. NGAD focuses on air superiority platforms designed to penetrate heavily defended airspace, but the program has faced repeated delays and budget constraints. Current projections suggest American 6th-generation fighters won't enter service until the mid-2030s, potentially 5 years behind Russian deployment. The technological gap widens when examining production philosophies. Russian defense contractors operate under centralized direction, enabling rapid resource allocation and decision-making. American programs must navigate congressional oversight, contractor competition, and bureaucratic approval processes that slow development at every stage. Europe's response has been equally fragmented. The Future Combat Air System, jointly developed by France, Germany, and Spain, aims for operational deployment by 2040. However, disagreements over workshare, technology transfer, and program leadership have created delays that push meaningful progress even further into the future. Britain's collaboration with Japan and Italy through the Global Combat Air Program offers more promise, targeting service entry in the early 2030s. This program emphasizes artificial intelligence and autonomous systems, potentially creating capabilities that rival Russian developments. But international coordination challenges remain significant obstacles to meeting ambitious timelines. China's Baidu program adds complexity to global calculations. Intelligence assessments suggest Chinese sixth-generation development focuses on Pacific theater requirements, emphasizing long-range strike capabilities in carrier-based operations. This specialization could create regional advantages that complement rather than compete directly with Russian air superiority platforms. Russia's timeline advantage stems from strategic decisions made years earlier. The Advanced Research Foundation began sixth-generation research in 2014, while Western programs didn't receive serious funding until the late 2010s. This head start, combined with centralized development approaches, has created momentum that Western programs struggle to match. The implications extend beyond individual aircraft capabilities. Russia's approach integrates sixth-generation fighters into broader military networks, creating system-of-systems advantages that multiply combat effectiveness. These platforms coordinate with ground-based air defenses, satellite networks, and electronic warfare systems to create layered defensive umbrellas around strategic assets. NATO's response has evolved from skepticism to alarm as Russian capabilities become clearer. Alliance planners now acknowledge that air superiority assumptions underlying current military doctrine may become obsolete within the decade. Traditional approaches to power projection and conflict escalation require fundamental revision when facing adversaries with hypersonic, AI-enabled platforms. The economic dimensions are equally concerning for Western planners. Russia's component testing approach requires less upfront investment than developing entirely new aircraft, making sixth-generation capabilities accessible despite economic sanctions and reduced defense budgets. Western programs demand massive financial commitments that face political resistance in democratic societies. Production timelines reveal additional advantages for Russian approaches. While American F-35 programs have struggled with manufacturing bottlenecks and quality control issues, Russian incremental development reduces production risks. Modifying existing Su-57 manufacturing lines requires less infrastructure investment than establishing entirely new production facilities. The strategic implications reshape global power balances. Nations traditionally dependent on American air superiority guarantees face uncomfortable questions about future security arrangements. Russian sixth-generation capabilities could neutralize American forward deployment strategies that have maintained regional stability for decades. Middle Eastern and Asian allies are already exploring alternative security partnerships as confidence in American technological leadership wanes. Russia's successful integration of sixth-generation systems could accelerate these geopolitical shifts, creating new alliance structures that challenge Western influence. The arms race extends beyond national capabilities to include export markets. Countries seeking advanced fighter aircraft face limited options, with American platforms restricted by technology transfer concerns and Chinese systems lacking combat validation. Russian sixth-generation fighters could dominate international markets by offering capabilities unavailable elsewhere. Defense analysts warn that current Western approaches may prove inadequate for the challenges ahead. The combination of Russian technological advancement, Chinese production capacity, and Western bureaucratic constraints creates scenarios where democratic nations lose aerospace superiority for the first time since World War II. But behind the bold proclamations and secret tests lies a troubling reality that exposes the true state of Russia's fighter program. What are they hiding? Despite Russia's bold claims about the Su-57 fighter jet, the facts tell a different story. 14 years after its first flight in 2010, fewer than 40 Su-57s have been produced. That's a tiny number compared to China's J-20 fighters and America's F-35s, which have been built in the hundreds and thousands. The slow production pace points to deeper problems in Russia's aerospace industry, made worse by economic struggles and Western sanctions since the war in Ukraine began. Even though production was supposed to start earlier, it only began in 2019, almost a decade after the jet's first test flight. What's even more puzzling is that the Su-57 hasn't been used in combat. Instead of being deployed in Ukraine, where Russia could use its most advanced weapons, these jets have stayed within Russian borders, used only for air patrols. This raises serious doubts about whether the Su-57 is truly ready for battle. Western experts say there are major flaws that Russia isn't admitting to. the Su-57 doesn't seem to be as stealthy as advertised, and its radar signature is bigger than that of rival jets from the United States and China. In short, it may be more like a souped-up version of older jets than a cutting-edge stealth fighter. Another big issue is the engine. Instead of using a new fifth-generation engine, current Su-57s still rely on older engines from the Su-35, which limits their performance. The new engine is still in development, leaving a gap between what Russia is promising and what it can deliver. The export market isn't buying into the hype either. Russia has only just secured its first export deal, and even that buyer hasn't been officially named. Algeria is rumored to be the customer, but the secrecy and heavy discounts being offered suggest Russia is desperate to make a sale. Even India, one of Russia's closest defense partners, has expressed doubts. Indian officials have concerns about the jet's stealth and overall performance, showing that even longtime allies aren't convinced. Russia's messaging around the jet also doesn't add up. Officials claim to be testing sixth-generation technologies now, while also admitting that actual sixth-gen jets won't be ready until the late 2020s. This inconsistency suggests either false advertising or unrealistic timelines. Meanwhile, Russia's ability to build more jets is limited. The war in Ukraine has pulled resources away from aerospace projects, and sanctions have disrupted the supply of key parts. On top of that, quality control issues and technical problems have slowed down production even more. Russia's defense budget is also feeling the strain. With money and manpower going to the war, there's little left for large-scale aircraft development. What looks like a smart approach to testing new tech may be a way to cut costs. Perhaps the most embarrassing moment came recently when Ukraine reportedly hit a Russian airbase and damaged or destroyed a Su-57. That kind of vulnerability casts serious doubt on just how advanced and stealthy these jets are. All of this adds up to one thing. Russia's big talk about sixth-generation fighters looks more like smoke and mirrors than reality. Experts believe these claims are more about saving face on the global stage than showcasing real progress. And as long as Russia remains isolated and under pressure, its ability to keep up with global military tech seems increasingly unlikely. Despite the mounting evidence of problems and delays, one critical question remains unanswered. Is Russia's sixth-generation program a revolutionary breakthrough or an elaborate deception? The evidence presents a complex picture that defies simple conclusions. Russia has undeniably conducted extensive testing on Su-57 platforms, with over 700 documented flight hours validating new systems and capabilities. These aren't paper studies or computer simulations. Actual hardware has been flying and generating real performance data since 2023. The technological components appear genuine. Advanced electronic warfare systems, improved radar capabilities, and enhanced networking functions represent measurable improvements over existing platforms. Russian engineers have successfully integrated these systems into operational aircraft, demonstrating technical competence that Western analysts cannot dismiss entirely. However, the gap between component testing and operational deployment remains vast. Installing sixth-generation systems onto fifth-generation airframes doesn't create true sixth-generation fighters. The fundamental limitations of the Su-57 platform, questionable stealth characteristics, engine performance constraints, and manufacturing quality issues cannot be overcome through software upgrades alone. The timeline analysis reveals Russia's strategic predicament. American NGAD programs target deployment in the mid-20s, while European FCAS and GCAP initiatives aim for similar timeframes. China's Baidu program follows comparable development schedules. Russia's claims of operational sixth-generation capabilities by 2030 would represent a 5-year advantage over competitors, if genuine. This timeline advantage carries enormous strategic implications. 5 years of technological superiority could reshape global military balances, potentially neutralizing NATO's conventional advantages and forcing fundamental changes to alliance defense strategies. The stakes justify significant investment in deception operations if Russia cannot achieve genuine technological breakthroughs. The production numbers tell the most revealing story. Fewer than 40 Su-57s in 14 years of development cannot support claims of imminent sixth-generation deployment. Even if Russia achieves perfect integration of new technologies, Manufacturing capacity constraints limit operational impact. Advanced capabilities distributed across small numbers of aircraft provide minimal strategic advantage. Financial pressures compound these limitations. Russia's defense budget faces competing demands from ongoing military operations, while international sanctions have disrupted supply chains for critical aerospace components. The component testing approach may represent cost-cutting measures rather than innovative development strategies, suggesting resource constraints rather than technological confidence. The export market response provides another crucial indicator. Despite aggressive marketing campaigns emphasizing sixth-generation capabilities, international buyers remain skeptical. Traditional Russian defense customers, including India and Algeria, have expressed reservations about Su-57 performance and reliability. This hesitation from established partners suggests underlying concerns about program credibility. Western intelligence assessments increasingly characterize Russian sixth-generation claims as strategic deception designed to maintain technological credibility despite mounting evidence of program difficulties. The gap between public assertions and observable reality suggests a military industry struggling to maintain relevance in an increasingly competitive global market. The geopolitical context supports deception theories. Russia faces growing international isolation, economic sanctions, and military pressure from multiple fronts. Maintaining the perception of technological competitiveness serves important strategic purposes, even if actual capabilities lag behind claims. The psychological impact of sixth-generation announcements may provide deterrent value regardless of operational reality. Yet dismissing Russian capabilities entirely would be premature. The Soviet Union achieved genuine technological breakthroughs despite economic constraints and international isolation. Russian aerospace engineers possess significant expertise and have demonstrated innovation throughout decades of aircraft development. The possibility of legitimate advances cannot be entirely discounted. The most likely scenario combines elements of both breakthrough and bluff. Russia has probably achieved genuine improvements in electronic warfare, networking, and artificial intelligence integration. These advances represent meaningful progress towards sixth-generation capabilities without constituting complete technological transformation. The final verdict may depend on factors beyond pure technology. Russia's willingness to accept risks that Western programs avoid, combined with centralized decision-making processes that enable rapid resource allocation, could produce operational capabilities that exceed paper specifications. However, sustained technological leadership requires industrial capacity and financial resources that current Russian circumstances cannot support. The truth likely lies somewhere between Russian claims and Western skepticism, significant but limited progress toward ambitious goals that remain years from full realization. Thanks for watching. While you are still here, click on the link on your screen to check out another of our videos. See you there.